14.7 Statistically significant results. It's important that you accurately interpret the findings of others, often reported as having statistical significance. Tests of hypothesis often are referred to as tests of significance, and test results are described as being statistically significant. Rejecting the null hypothesis and statistically significant both signify that the test result can be attributed to chance. However, correct usage dictates that rejecting the null hypothesis, others refer to the population, such as rejecting the hypothesized zero difference between two population means, while statistically significance always refers to the sample, such as assigning statistical significance to the observed difference between two sample means. However, assigning statistical significance to a population mean difference would be misleading, since a population mean difference equals a fixed value controlled by nature, and not something controlled by the results of statistical tests. Statistical significance implies only that the null hypothesis is probably false, and not whether it's false because of a large or small difference between population means. Using excessively large sample sizes can produce statistically significant results that lack importance. Statistical significance merely indicates that the observed effect, such as an observed difference between the sample means, is sufficiently large relative to the standard error to be viewed as a rare outcome. It's very desirable, therefore, that we go beyond reports of statistical significance by estimating the size of the effect and, if possible, judging the importance. PR, the observed result given HO, is true, less than or equal to 0.05. PR HO is true given that the observed result is less than 0.05. 14.8 Estimating effect size, point estimates, and confidence intervals. Point estimate, x bar 1 minus x bar 2. It identifies the observed difference for x bar 1 minus x bar 2 as an estimate of the unknown effect, that is, the unknown difference between population means, mu1 minus mu2. On average, the treatment patient stays on the treadmill for 11 minutes, which is almost twice as long as the 6 minutes for the control patients. If you think that it's the impressive estimate of effect size, isn't it surprising? Confidence intervals for mu1 minus mu2. Ranges of values that in the long run include the unknown effect of a certain percent of time. Although simple and straightforward and precise, point estimates tend to be inaccurate because they ignore sampling variability. Confidence intervals do not, because they are based on the variability in the sampling distribution of x bar 1 minus x bar 2. Confidence intervals for mu1 minus mu2 specify ranges of values that in the long run include the unknown effect, difference between population means, a certain percent of the time. Confidence interval CI for mu1 minus mu2, two independent samples, is x bar 1 minus x bar 2 plus or minus t confidence times x bar minus x bar. The numbers in the confidence intervals refer to differences between population means, and the signs are particularly important since they indicate the direction of these differences. The key point is a single interpretation is possible only if the two limits of the confidence interval for mu1 minus mu2 share the same signs, either both positive or both negative. Progress check 14.7. Which confidence interval is most precise? The answer is 2. Which confidence interval most strongly supports the conclusion that EPO facilitates endurance? The answer is also 2. Which confidence interval most strongly supports the conclusion that EPO hinders endurance? The answer is 3. And then, which confidence interval would most likely stimulate the investigator to conduct an additional experiment using a larger sample size? The answer is 1.